Hello and welcome back to KXAN Plus. Thanks for joining us. We have our space segment here with our space expert, Eric Henrickson. Eric, thanks for joining me. How you
I'm
doing?
doing great.
A little giggly this
I'm a
morning.
little not too giggly. I'm like the right. I think I'm like the right amount of giggly. The right amount of giggly where you get stuff done, but you're not too serious while you're doing it.
Oh, so you're having fun while getting the things that you need to do
Yeah.
done.
After this, I'm eating lunch. That's.
So you're doing the lunch
I
dance.
got this show prepped, and then I'm gonna go eat lunch, which is a salad. It's a Tuscan salad. You guys don't need to know this
Ew.
information. No, it's good. It's got sun-dried tomatoes in it.
Salad
Yeah.
for breakfast,
Well, lunch. I've been here. I got here early. It's not
I guess.
lunchtime for me. Yeah, no, it's like a reasonable. It'll be like 11 when I eat. It'll be fine.
Yeah, it'll be fine. And
I
then
used
you're
to.
done.
You want way too much information for a live stream we're sharing with everybody? I used to come in at 4 a.m. and I'd eat like a salad at 7 a.m. and people would judge me. But I was like, I got up at
That
3.
is crazy work.
But yeah, it was like I got here early. So for me, like 7's lunchtime, I don't scoff at people if they're eating at, noon if they get here at
Because
9.
when you're eating in the morning when you get here, no one's looking at you, so they don't know that you already had breakfast, probably had your snack, and now it's lunchtime.
Anyone who's looking at me knows that I'm just eating all day long anyway. It's just a constant. I already had like 3 Werther's Originals this morning alone.
Wow.
Because I'm just like an eating machine. Speaking of eating, the universe might be eating itself.
Is it? Is it true?
Maybe, possibly, could be. That's our topic today.
Yeah, it is. So, they are thinking that the expansion of our universe is not as fast as we thought it was.
In fact, slowing down.
Oh,
Ooh,
slowing down.
twist, right?
So we're gonna disappear slowly.
Oh, maybe not that slowly. I'm making this really foreboding when it doesn't need to be. Okay, so let's talk about it. So the universe has always been thought as this thing that is constantly expanding, expanding. Dark energy, that it's this energy that exists between the atoms of things, is thought to be pushing things apart at all times. Now, not to the point where like we're like exploding or anything, but it slowly but surely everything's being pushed outward and outward. And there's this new research out of Korea that was published just last week, Friday, I think, that in the monthly notices of the Royal Astronomical Society, and they used observations from the Dark Energy Spectroscopic Instrument DESI, that's located in Arizona, that's used to map the entire universe. And they used observations from that on a specific type of supernova. And now they believe that that dark energy that's pushing things apart might not be pushing them apart as fast, and the universe might be slowly down over time of that expansion to eventually maybe stop and maybe do something else afterwards.
And I know this is not happening during our time here in the
I
universe,
mean, it is, but like
but
not,
well,
it
it's not
won't,
gonna disappear.
right. When we're talking about, so I was talking to a scientist the other day, and they were talking about for them, this was like a micro scientist. They were talking about things being quick when they happened,
Yeah.
things happening slowly when they happen in nanoseconds. That was for them. And then for astronomers, it's the opposite. Things happen slowly when we're
Quickly.
talking about, you know, quadrillions of years, trillion years, billions of years. That's like a normal time frame for an astronomer. So yeah, we're talking trillions of years, billions of years of time
Until this actually happens.
until the universe like expansion stops.
Mm.
Possibly billions. I'd say billions. I don't say trillions. I'll
And
say billions of years.
what does that mean for the universe when the expansion eventually finally
That's
stops?
a great question. If this is true, if this theory is true, and I'll get to more of the details of it, uh, it could mean that one of the ideas is this idea called the Big Crunch.
Yeah, I've heard that before.
Yeah, and the Big Crunch is basically things go out, and then they
Explode.
come back and crunch in. Eventually, all the matter in the universe gets sucked into a single point. And then possibly one of the other theories after that is that it would then go again and form another universe. So you have these cycles of expansion
Another
and
Big
crunch.
Bang?
Yeah, exactly. That's one theory of how like universes form. This is so like esoteric, isn't it? So out there. How do universes form? This is the one possible theory about the timeline of our current universe. Of course, we would all be, even if we did exist for that long length of time, we'd be wiped out during that collapse, and then possibly something else happens afterwards. Who knows? That's one theory. Is that it would keep it? One theory is the universe keeps expanding outward for eternity. The other theory is that it would go out and then collapse on
And then
itself.
crunch.
And
back
there's something called
inside.
like the heat death of the universe. but I'm not going to get into that. Basically, it's like everything just kind of overheats.
I feel like that's just a summer in Texas.
Yeah, this is a Texas summer death of the universe.
It
So
feels like it.
different processes with which the universe lives and breathes, and this is one of the ways that could. But the theory that these scientists have from Korea is that it is expanding still, but that expansion is slowing, and they came to this conclusion by observing Ia supernovae, which are a type of supernova that occur in white dwarf stars.
Mm.
And these are kind of called the standard candles. That's the quote everyone used on the internet while I was reading up on this. These type of supernovas, they exist. They're all like the consistent brightness, and they no matter where they're at. So or when they formed is the idea. Like so, you have a supernova that occurred, an Ia supernova that occurred 20 billion years ago. The universe is that old. Let's say 5 billion years ago.
Dang, we're old.
I know we're not that old. Yeah, I was jumping too high. So 5 billion years ago. Let's say it's 5 billion years old. You know, that would have the same brightness as one that was formed 100 years ago.
Wow.
So you can tell by based on their location, because the brightness is consistent where their movement over time, and that's why we think the universe is expanding. Well, they think this research looked at this and said, well, we think some of those supernovae, if they're born from older stars, they're brighter, and if they're born from younger stars, they're darker. Which could mean that these are not as consistent as we thought, and it's kind of revealing like some of the gaps in our logic, possible gaps in our logic, and where that this expansion might not be tracked as much as we think, and it may kind of reconceive what we think of dark energy. One of the researchers on the project talked about like this dark energy and what this means for like this slowing down, this collapse, and here's what he had to say about that.
Let me pull that up.
I cued you quick.
Still there, but this pressure has been weakened compared to previously thought. So that's the reason why the universe is not accelerating even at present epoch, not to mention the future. And then the destiny of the universe will be changed because of our interpretation of the dark energy has been changed. So instead of ever expanding universe, and probably could end up with a big leap with very cold temperature, so-called the big crunch is now within the possibility, but we cannot guarantee that this will happen, because to know that we need to know the true nature of the dark energy, but we still do not know the true nature of the dark energy, so we need more work.
So basically, they're pushing for more research into dark energy to decide, hey, is it really like not pushing? Is it not causing this expansion?
Is it
speed?
happening or not?
Is it slowing down? We just don't know enough. One of the guys who did the initial research, so when we discovered dark energy and kind of confirmed its existence in 2011, they won the Nobel Prize in physics. Yeah, physics, I think. Dr. Adam Rees with Johns Hopkins, he argues that this paper, and a bunch of people are kind of really saying, no, this can't be true. This paper, it's one paper out of a bunch of papers, by the way. So keep that, it's with a grain of salt.
And is
he argues, I'll finish this thought real quick. He argues that we have so much limited data on these supernovas, these supernovae, the scientific name, that because of that, their data they collected on this research paper is not good. He's like, hey, the data you're using doesn't match up with the data we have because we don't have enough data already. Yeah. So it's like, whose data is the proper amount of data?
Where did you get this from?
Right. And like if you got this from this location, we don't really know enough about that data to, it's like if 2 + 2 = 4, but someone came up to you and said, well,
it equals 5.
But 2 could also equal 3. Yeah. But then you're like, well, now you're putting that thought into question. Maybe we need to learn more about 2.
Yeah.
Before we can decide if 2 = 5 or 2 = 4. So that's kind of where it's at. It's like we don't know enough about one element in this puzzle to make a declaration that the universe is slowing down. And that's what some groups are arguing. These researchers are arguing we need to study more dark energy because we need to understand if this slowing is occurring. So it's kind of like, are we using the proper data in this scientific equation to come up with a conclusion? And who knows? I don't know. And we probably will all be dead before they have an answer. Because something that, again, is like billions of years old. Unless something changes that we humans live billions of years, I don't think we're going to learn this answer in our lifetimes. But maybe the human race one day will, and they'll uncover this live stream here at
Yeah,
KXAN Plus
maybe they will
and go,
pop up this live stream and
those
say
people.
they had it right.
And they had it right, and maybe they didn't. Who knows?
So this study is coming from Korea. You mentioned that in the
Yes.
beginning. We heard your comment about one other university and what they thought related to this study, but what
hmm
were all the other universities' reactions
I
when
only
they saw this?
saw a few more, and a bunch of them were just kind of interested, and a bunch of them were like against it. So it is kind of like all over the place. It really
Was there
is.
a lot of debunking? Like, that's for sure not true.
Not a lot yet, but again, the paper was published like last week, so
Fresh.
that may come in the future. You know, the argument over what they believe is occurring in these supernovas, are they really changing the brightness, magnitude of brightness, or was the instrument just detecting something weird? That's going to be the next thing. You know, that's the thing about science. It's all about like you get a hypothesis, you come with a conclusion, then that conclusion gets tested over and over and over and over and over and over again until we have a good understanding of it being close to true or not.
Yeah.
You know, and when people talk about like the theory of evolution, the theory of gravity, when you have a theory in science, something that's called a theory, it's usually something that's been tested over and over and over and over and over and over again to the point where they're pretty sure it's true.
To the
Uh,
point where they're making sure it's true.
it's like, yeah, they're like this. The likelihood of because science, you never declare something's 100% true or not. It's
Mhm.
99.99999% accurate. And so for something like this, where this is the first idea. Actually, it's not the very first. Someone else has put this forth a while ago, the same idea in a different paper.
Mhm.
But and in fact, Dr. Adam Rees argued, said, hey, like we've seen this argument before from similar scientists. It needs to be tested and tested and tested. So we'll see what happens. Maybe in the the next couple of years here, we'll have a more definitive answer on this particular research.
Yeah, and this one's pretty interesting. I want to know if our universe is gonna collapse
Yeah.
before I die.
I think you'll be good. I think we'll be fine.
I think we'll all be good.
I think we'll also like you think about it this way. Ooh, we get kind of wild
Really
out there. Here.
spooky.
Yeah, if you think about the amount of time it takes for like light to travel, even if the universe is collapsing, by the time it collapses back on us,
Mhm.
by the time we know it's collapsing, by the time it actually reaches us, I mean it'll be billions of years, hundreds of millions, if not billions of years, and the human race
You won't even know.
won't be around. Yeah, so it may be something like going, oh no, it's all going to end. Osmandius poetry and stuff like that. All this stuff we built, lost in the desert. You gonna talk about some moons?
Yeah, this is not our only topic. We're talking about some moons. And lately we've had beautiful moons in our sky.
We have. I think we get like just kind of better ones in the fall when the Earth and the moon are kind of like the Earth's kind of more in the dimmer part,
Darker,
Yeah, it's
earlier.
the Earth's tilted or as it moves away from the sun, so it's kind of further away. It's just a little easier to see a lot of times. I've noticed like early morning, not even that early, like 7 a.m., 8 a.m. I can still see it pretty good. And
I can driving home at 5 p.m. I
Yeah.
can see it perfectly.
It's like out early and,
Yeah.
and up early. So good moons. But this one we're talking about is a quasi moon.
How do you say that? Quasi?
Quasi. That's how I've
Quasi-moon.
always said it. I don't
And
know.
it's detected in this
yes,
year.
its name is 2025 PM
2025.
7. And what makes this quasi moon interesting is it is not a real moon.
Boo.
It's not. So we have like mini moons that do orbit Earth. Like we have the big moon, Luna.
The
as its
main
name.
moon. The main moon.
Main moon, Luna is what we call it. That's the Latin name. I don't know if it's Latin name or like just the main
It's
name.
Spanish.
Celine. Well, Spanish is Latin, right?
Yeah.
So it's like, okay, anyway, Luna. And then we have like little mini moons that orbit Earth that are like really, really tiny. They're basically like small asteroids and stuff that are whipping around. But this is a quasi moon. I hadn't heard of a quasi moon before. And Brandon Johnson with Purdue University gave a cool lecture to AP, the Associated Press. And I have that here. And he kind of explains what this is and how long it'll be here. And it's really cool. I think it's worth sharing. So check it out.
Yeah, so these quasi-moons are quite rare, but they're not completely unique. So there are 6 other quasi-moons that we know about. My name is Brandon Johnson. I'm a professor of Earth, Atmospheric, and Planetary Sciences at Purdue University. A quasi-moon is a body that orbits the sun, but goes around the Earth once every year. Their orbits are pretty interesting. So they're all very close. Their orbits are very similar to the Earth's orbit. And that means we could send spacecraft to them much easier than we can send them to any other asteroids in the solar system. So if we were able to send a spacecraft to these asteroids, we could learn a lot more about their compositions, their histories, and that could tell us a lot more about the history of the solar system. 2025 PN7 is an asteroid that's about 60 feet wide and has an orbit that's very similar to the Earth's. But its orbit's special, so it's elliptical or a little bit elongated. And what that means is when it's closer to the sun, it's going faster than its orbit than the Earth. So it catches up and passes the Earth. But when it's further away from the sun, it's actually going slower, and so the Earth catches up and passes the asteroid. And from our viewpoint on the Earth, that orbital dance makes it seem like this asteroid is going around the Earth once every year, and that's why we call it a quasi-moon. So I think one thing that's fun about this object is some people called it a second moon, and then there was debate about whether it really is a second moon or not. These quasi-moons do appear to go around the Earth, but they're not captured by the Earth's gravity, and so that's why astronomers classify them as something separate than these mini-moons that come by from time to time. 2025 PN7 is pretty small. It's only 60 feet wide. And so you need a really large telescope to be able to see it, with a mirror larger than a few meters. And so the average backyard astronomer is not going to be able to see this with their telescopes. Yeah, so this quasi-moon will be around for about 60 years from now. And after that, it will no longer be in this special orbital configuration where it goes around the Earth and appears as a companion of the Earth. And it's pretty unlikely that it's going to come back and become a quasi-moon again after that.
So this is not a moon, it's a rock.
Well, it's an asteroid.
It's an asteroid.
Quasi-moon. It's a moon that has a fake orbit with Earth.
It's a fake moon. That's what it is.
Several decades. It is a fake moon. Yeah, it's a quasi-moon. It does have an orbit. It's orbiting our sun.
But he said that it doesn't have any pull. Like
No.
the Earth does not pull it. The moon does not pull it.
It's trapped in the gravitational well of the sun. You and I were talking during it about it's 60 feet, and you said that's big. On the newest season of a Great British Bake Off or baking show, whatever you call it, based on the copyright, they had to make a 3-foot long cake.
3 foot long cake?
3 foot long cake. And on Earth, that's a huge cake. In space, you would never see that cake.
Floating around like an alien's birthday cake.
Yeah. And I kept thinking, like, gosh, it's amazing what we consider big here. I looked at this cake, and I'm like, that's the largest cake I have ever seen.
3 feet? Who wants a 3-foot cake? How many people do you need to eat a 3-foot cake?
Well, I got some parties at my house, let me tell you. We have a lot, actually. Whenever I bring desserts for parties, no one eats them these days. Everyone's like, protein, myself included.
No, they take them home and they eat them.
Yeah, they eat them in secret. They turn the lights off. So my point is, size is all relative, right? You think a 3-foot cake's too big. I think it's too small. And then this asteroid, and you said it's big, and I said it's too small. So it's it's all relative. And when it comes to space, things get big.
Nothing is too big in space.
I was watching something the other day about like how far away is the Earth from the moon, and it's like if this is the Earth, the moon's like way like over here. It's not close. It looks if it's big though. So like if this, let me get this in the shot there. It's like that. It's like that far away. Like that's thank you. We do like that gestures and stuff. So it's like space is like huge. Everything's big. It's big. Like it's so big, and we're so small and insignificant.
You're scaring me, Eric.
Sorry. But it is like space is really big, and so when we talk about space, we're always talking about like giant things. So something that's 60 feet across may sound big on Earth. That's 6 stories, but you could not see that with your naked eye.
Doesn't even phase our moon or our planet.
No, it's a blip. It's a surprise that we even spotted it. Yeah. It's so small.
And that seems to be a common occurrence with all of the new things spotted that we talk about here.
We have better technology now than we did, a year ago. So spotting these tiny things is a lot easier, which is great for us if something big does come. But also that means we shouldn't freak out when everything that pops in the sky because there's small stuff. But it is cool to discover, like, hey, we get like kind of quasi moons occasionally that kind of orbit the solar system and makes us feel like we have an extra moon that's 60 feet across.
And it's staying until 2083.
Yeah, it's staying. Yeah, what's that? 60.
I'll be 83.
58 years. Did I do the math right? Yeah, something like that. 58 years. So it's like 58 years it'll be here. So then it's out. So it's like, yeah, it's pretty cool that we get these things that kind of float in and then disappear.
And they're gone. We
One
don't
more
know where they
One
went.
more thing that floated in. You want to talk about our alien comet?
Oh, yes, my favorite.
All right, so this has been driving me crazy. I should say it still. Sorry, guys. This has been
Hey,
driving.
that's Erica's show.
Oh, she did the same thing.
Her KXAN Plus show is driving you crazy.
Oh, is it really? I didn't know. I watched the show. I didn't know that was the name. I apologize, Erica. But Three Eye Atlas. Have you heard about Three Eye Atlas, America?
No.
You and I talked about it.
Here?
Yes.
3-Eye Atlas.
Yeah.
Is it an alien?
That's our alien rock.
Oh, yeah. Is it an alien?
It's not an alien. I was watching some news programs and people were on there going, "Is this the aliens coming in?"
Are they rocks? Are they
They're
going
rocks.
to throw themselves at us?
It's a comet. It's a comet, everybody. But it came from outside of our solar system, which is unusual for us to spot something that comes out from outside the solar system and to have something visit us that's not from here. And it came in July. Sorry, I'm remembering dates. And it zipped past our solar system. It's already past the sun. It's going to do
Oh,
do the wide shot so I can do the
Let's.
hand gestures. If this is the sun, it came out and it's like kind of goes out and then it'll zip out. And it's kind of already done this part and it's like here and it's going to go out and it disappears. So it's
And
already past our sun and it just kind of uses it's parabolic is the shape. It does a parabola. Launches off into space. So
And what
that's what's doing.
launches it? Like, it has to
Gravity.
have power to stop
What?
and then
No,
launch.
gravity.
Gravity?
Gravity. It's all gravity. You remember, if you ever go to like a grocery store, and they have these giant funnels in the grocery store, and you take a penny or a quarter, and you push it down the edge of the thing, and it swirls down to the bottom. You know
What
I'm talking about?
grocery store are you going to? Oh, the little things.
You're making me feel really
The
old
little
right now.
toys?
Yeah. So toys. And it used to be for like donations and stuff back in my day. But those things, that's how gravity works. If you things moving fast enough, it can zip out of there. If it's moving too slow, it gets pulled in.
Yeah.
So this object is just flying
Pretty
through
fast.
space fast enough that when it hits the stars, the sun's gravity, our gravity, whatever gravity it hits, the sun's gravity, it just gets turned like in those big spirally things. I love that you have to go to the wide because I'm doing so many weird hand
Your
gestures.
wingspan doesn't even
I'm
fit in the
so
wide.
big. I'm so big. I'm 6'6", guys. As it comes in and does this instead of like spinning, and if it's going too slow, it gets into orbit. If it's going way too slow, it falls into the sun. If it's going just right, it comes in and zips out, and so that's what it's doing.
And Eric, why do they call this the dirty snowball?
Because it's a comet.
Comets are dirty?
Comets are dirty snowballs. Anyway, well, here, Christopher Palma with Penn State University explained this in a lecture. Here's him explaining 3-Eye Atlas, why it's a dirty snowball, and why it's not aliens. Here, take a look.
Comets are, we refer to them as dirty snowballs. So they're a mix of rock and ice. Christopher Palma, I'm a teaching professor in the Department of Astronomy and Astrophysics at Penn State University. So there's this very interesting comet right now that's called 3-Eye Atlas. The name Atlas in this case is the name of a monitoring telescope that's funded by NASA that is looking for objects that could be potentially hazardous to Earth. And by the way, they accidentally discover comets all the time. Picture someone able to like slice a rocky mountain off of Earth and then just put it in space. Like they really do look like a cliffside with a rock fall. But they're covered in like fine ice as well. So if you take this thing and you move it close to the sun, that ice is going to heat up. And so the ice particles will start to drift off away from the original comet object, and it creates a tail. But this one, 3-Eye Atlas, is really interesting. It's what's called an interstellar comet. That means it actually came to our solar system from another star system. So this comet was not born around the sun. It was born elsewhere. It's been drifting through space on its own, and it just randomly encountered the solar system. And so it's on what's called a hyperbolic orbit. It's going to pass, it already passed by the sun, and then it's just going to keep going, never to come back again, heading back out into interstellar space. So when we discover these objects, we have these ideas for how did our solar system form? How did Earth form? How did Jupiter form? How did all the asteroids and comets that are orbiting the sun form? And we think that process is the same everywhere, but we can only be certain of that if we can test it. And we can't go to another star system and grab a comet. They're so small that you can't see them at any distance away. So these 3 interstellar comets have given us the opportunity to study comets that were born elsewhere to test our ideas for, are we right about how planets form and how comets form? A lot of people have pointed telescopes at this. The telescopes show in every way that this is a normal comet, but there are some voices out there that persist in saying it's aliens. So I'm here to tell you it's not aliens.
Well, I'm here to tell you I wish it was.
I knew you were going to say something. I was like, Esme's going to say it's aliens. It is not aliens. It's just a comet.
It's just a rock.
With people living inside of it. No. It's just a comet. It's just a comet. It's just a comet. It's 3I Atlas. 3I. Third interstellar.
The rock has 3 eyes. There's 3 people on there,
There's
and
a
they all have 3 eyes.
Third of these interstellar objects we've seen. And it was spotted with the Atlas. I forget what that acronym stands for, but Atlas. It's one of the devices for measuring.
But this one specifically is not common, right? It's rare.
It's rare to have anything from the outside of our solar system
enter ours, yeah.
Again, because space is big, it's just hard for things to, and if they do, it's hard for us to detect them. We probably have had other things that are outside of our solar system come in, but just we just don't detect them.
Yeah,
but
unless we're looking for them, right?
Right, and even then, again, like we mentioned before, it's like the technology's evolved, and now we're capable of detecting them. I mean, keep in mind, like a lot of our planets past Jupiter, all those planets past Jupiter are relatively recent discoveries in our solar system.
Mm-hmm.
So, Galileo found Jupiter, but I don't remember when Saturn was found, but it was further out. And then like Uranus and Neptune were much further, and Pluto is not a planet anymore. But even that was relatively recently. So those are planets. They're big.
Yeah.
And then a dwarf planet when it comes to Pluto. They're big. The number of moons around Jupiter, there's a lot of them, and they're big. They're like the size of the Earth. So,
and that just shows us how huge our solar system is. And
right, and it's bigger than you think too. It doesn't just stop at Pluto.
It keeps going.
There's the Oort cloud. Have we ever talked about the Oort cloud? It's like the debris of our solar system's construction, and it's just a big kind of like cloud of dust that surrounds our solar system, and it surrounds all. I think it surrounds all solar systems. I want to say. I don't know for that for sure.
Is it like a layer of protection, or
it's just leftovers? It's like when you eat a bunch of food on the couch and then you stand up and there's a bunch of little crumbs
Ew.
that outline your body. This doesn't happen to you?
No.
Okay, maybe this is just a me problem. But that is my Oort cloud from after I've consumed all that food. And so after all the planets have consumed all the rocks, and even our asteroid belt, that's leftovers. That's from a planet was forming and didn't quite have enough material to form.
So just like debris.
Yeah.
Is there like garbage that we've left in our solar system out there in that area?
I wouldn't call it garbage, but the Voyager 1 and 2 are out there. That's the furthest we've sent anything. It's far. We launched them in 79 and 81, I want to say.
Why all the way out there?
We just launched it. And then those satellites, or those, do we call them satellite probes? Voyager 1 and 2, it was we have like pictures of humans. We have like a record on there that has information about us. We have like
we're trying to communicate with the aliens.
It has information on there in case someone runs across it. But the whole idea was to send it out and take photos of like Jupiter and Pluto and stuff. So they went out and to the deepest parts of our solar system to take photos. It's taken them 50 years, and they're still in the middle of the Oort cloud. They're not outside the solar system yet. Wow. And we still get signals back, I think, from Voyager 1. I don't know if 2 does.
I wonder. That's something we can look into.
We have gotten signals from those fairly recently. Well, one or both of them, I can't remember. Just letting us know that they're still alive. They're still kicking. Just floating out to oblivion.
By itself.
By themselves in the deep dark.
That is scary.
No, it's not scary. It's lonely. Just lonely. I don't know. That's why we're better off here with each other.
Well, we have this article that you just published on our website. It's about the first topic we covered.
Yes.
The controversial paper suggesting that our universe expansion is slowing down.
Yeah, I have a few more quotes in this one to help you understand kind of where their thinking is on the slowdown. Is it really happening? No telling. Again, this is one of those things. This is like early research, so we'll learn more about things. I do like that my headline was the end of all things.
This is scary.
Yeah, I like some drama.
So
Just
dramatic.
a little bit of trauma for my stories, but yeah, it's I think it's interesting. I think it's interesting research for sure. Something we should think about. Is our universe slowing down? And also because we have dark energy between all atoms. We have them between ourselves. So are we slowly expanding?
Oh,
I'm
I'm
about to-
vastly expanding.
I'm about to have lunch, and that's going to help with that. But didn't cheat. But I'm so sorry, guys.
I need some sound effects for all your little jokes.
I don't even know what's happening anymore. We're having a good time. We're here in the closet enjoying ourselves. So
In the closet.
I mean, we're in the all the darkness, and it's it's
There
not
it
too
is.
bad, but it's definitely a box. It's better than our Zoom room.
It's our little spaceship.
Yeah, it's our little spaceship. Someone asked me, they're like, do you like doing it in this room? And I'm like, yeah, and they're like, good, because it's really space themed.
It is.
So this is mine.
And our logo matches exactly.
I know it's
the room.
it was super cool that we have the spaciest of all the space shows and the spaciest room. So
They built it just for us.
they built it just for us.
Well, thanks for joining me, Eric. And this was fun. I can't wait
Yes.
for next week's topic.
We always have a blast. Thank you. A blast to see a space
Oh.
fun. Ooh, yeah.
See you next
See y'all
time.
next week.